Good morning, everyone. And we will have to tackle one more variable in kinematics. But before that, we will have to review first our instantaneous velocity concept. And this will be applied if the we want to get or calculate the instant velocity or the velocity in a particular second. Okay, an instant second, and we want to find the velocity of it. So that's instantaneous velocity. And then we should incorporate our derivative concept in calculating average velocity in instantaneous velocity. To calculate the average velocity, we have to substitute directly our final time and initial time in the problem to our function. And then in order for us to derive or to arrive the initial and final position, and then we will divide it by the change in time, and that's our average velocity already. On the other hand, we have the instantaneous velocity. We can calculate it by getting the derivative of the function and then substitute the instant second introduced in the problem. Okay, so in this problem, it's like the same with our previous problem, but yeah, maybe the function is really, it is changed into this way. So in Barangay Fiesta Indigos, a boy named Noy Noy participates in a thrilling version of Luksong Tinik using a colossal table instead of the usual scene. The aim of it is to jump on the table before jumping off. His motion after jumping off the table is describing by this height equation. We have the x of t is equal to negative 2t squared plus 12t plus 10. And then I guess this is, we cannot factor it easily. So maybe we will be using the quadratic formula. Okay, I provided the steps there and you can review it in your free time later on. So the x of t is the height in meters from the ground at the time that the that Noy Noy does not yet does not yet jump all the way to the top of the colossal table. And then time is the time in seconds after Noy Noy starts jumping off until Noy Noy lands on the ground. And remember, we will take the positive root of our answer later on because there's no negative time. Okay. So in this case, we have this function. Okay. And at first, it's here that Noy Noy's starting height, the height, or this is the height at zero time. And then from initial second or initial time, that's where Noy Noy is standing. But then the time that Noy Noy jump, yeah, the time is not, the time is also running. So therefore, we can say in this case that the starting height, it is in zero or at zero. In this case, we will substitute zero uh, to our function, and then after that we will be getting 10, right? Because everything multiplied to zero, it is 10, and the unit must be meter because it talks about the height. And then to get the time, so the time after, it's not June, it must be Noy Noy. Okay. So the time after Noy Noy starts jumping, we will be using now the quadratic formula. But before that, we will simplify our function here. Okay. We can simplify it by getting the common magnitude that will divide these three terms here. So we can have it by negative 2 in order for us to simplify our function. So by that, 2 divided by negative 2 divided by negative 2, you will have positive 1. So you have t2 in this equation here. And then 12 divided by 2, positive and negative. So you will have negative 6. And then positive 10 divided by negative 2, unlike integer, so you will have negative 5. So by that, you can apply the quadratic equation or the quadratic formula. It goes like this. Yeah, later on, you can be able to study the steps in detail. Okay. And if you're wondering, you have this square root of 56, we can still further break down this square root into getting its factor, right? So 56 is equal to, square root of 56 is equal to square root of 4 times 14. 4 times 14 is 56. And then you can extract 2 from that radical sign, and then our square root sign or symbol. So you will have 2 square root of 14. Okay, so it's here. 2 square root of 14 plus 6, and then we have 2 here. We will divide 6 by 2, so you will have 3, and then 2 by 2 is 1, so yeah, you will just copy negative 40. You can really get the decimal number of negative 14 if you like, but we will have to get the positive root of our answer for the time. So uh, it's just that we use the quadratic formula specifically because we cannot factor easily the given function. Okay, so that's it. This time we will be talking about acceleration. This is the last character of our kinematics. And it tells us how fast the velocity is changing over time. As I always say, that when there is a change in velocity, there is really acceleration. When the velocity is not changing, it's constant, there's zero acceleration. But the mechanical object, it's still moving. All right. And we have mechanics. Yeah. And then we will be focusing on acceleration this time. This is the fundamental formula to get the acceleration without using the kinematic equation. We will be knowing the equations or the kinematic equations or formulas in our maybe next lesson. Okay. And you will have the change in velocity over change in time. Change in velocity over time. That's the acceleration. Correction, we will be using V instead of S to represent the variable velocity. Okay, acceleration is a vector, so it has direction. But if the problem does not if the problem does not say or does not provide the direction, it's okay not to provide the direction in our final answer, provided that in the back of our mind, acceleration is a vector. It should have magnitude and direction. Okay. The car is traveling with an initial velocity 12 meter per second going east. It begins to accelerate at 4 meter per second squared uniformly. So therefore, in uh, in that case, same in this example, the car is traveling with an initial velocity 0.15 meter per second going east, and then the acceleration of the car is 12 meter per second squared 1 second. It's just like this is the meter per second. Okay, that's our acceleration. That's why we have a unit meter per second squared. Okay, that's the unit of our acceleration. All right. Um, in this simple problem, the car is traveling with an initial velocity of 0.15 meter per second going east. The car begins to accelerate at 2 meter per second squared, and there are questions that will let you you know find that will let you find the velocity at 5 seconds, and that's our given problem here. We have the initial velocity, we have the acceleration, the uniform acceleration there. So at 0 second, that's our velocity, initial velocity, and we should be very careful with the word initial. If this will be depicted or provided in the problem, meaning it starts at zero. So at 0 second, we have this velocity of 0.15, and then since we have the acceleration 2 meter per second squared, and that's constant all throughout the motion, you just have to add 2 meter per second squared, or the acceleration magnitude, to our initial velocity. So 0.15 plus 2, that is 2.15. Again, acceleration will be added to our velocity. So it's a uniform acceleration, so we will be adding 2 in every recorded velocity. It's changing because there is an acceleration in there. So from 0.15 plus 2, and then 2.15 plus 2, that will become to 4.15, 6.15, 8.15, and then 10.15. So if ever the question will let you calculate or find out the velocity at 5 seconds, all you have to do is to know your initial velocity, and then you will add the given acceleration until you will reach the fifth second in order for you to get the average, not the average, but the velocity at that particular second. Again, if you notice, the velocity is changing because it's accelerating uniformly at the same time. Okay, so we have this problem from the book. The car accelerates at 6 meter per second squared. It moves 2 meter at 1 second. What is the velocity of the car at 3 seconds? That's what I've told you earlier, that we have problems like this. Okay, so all you have to remember is to know the value of your acceleration, that's 6 meter per second squared, and then you have the velocity of 2 meter per second. It moves at 2 meter per second at 1 second. So this will gonna be our initial velocity. You have to add 6 to it until you will reach at 3 seconds. You will determine the velocity of it. Okay, so for example, at 0 second, it moves at 2 meter per second at 0 second. Okay, so in this case, zero, there's no initial velocity given at zero, compared to our previous problem that initially, and there's an initial velocity there. So zero, there is velocity going on in our previous problem, but this time it does not follow because it moves at 2 meter per second at 1 second. So therefore, our velocity at 0 second is zero. But there are cases that problem will provide velocity at rest, or initial velocity in, I mean, at 0 second. And you will just add 6. Sorry, not 6, but 2 is the velocity at 1 second. It's in the problem. Again, 2 meter per second, that's the velocity at 1 second. And then you will just add 6 because we need to find the velocity at 3 seconds. At 3 second, now you will have second, I mean 2 seconds, add 6, you will have 8. And then at third second, that's our, sorry, I cannot I cannot go back to the slide. So when you will add 6 plus 8, that's the velocity at 3 seconds. Okay. Again, uh, get the or you have to see the initial velocity. You have to know the initial velocity, and then the acceleration. You will just add it, and then in what particular seconds that the problem wants you to provide. Okay, so initial velocity plus our acceleration, that will determine the velocity every second of our motion. Okay, now a mechanical object is moving west at 8 meter per second at 6 seconds. Okay, So at 6 seconds, that's our time reference. At 6 seconds, the object is moving 8 meters per second west. That is negative. Okay, in the same direction, still west. At 9 seconds, the object is moving at 26 meters per second. So we have to give the acceleration of the object. Okay, so we have the formula. So we have to input everything there. So in this case, our we will be using V. I'm very sorry, V. V for velocity. So our final velocity is negative 26. It's negative because it's going westward. Minus the negative 8 meter per second. That's our initial velocity. And then we have the time, 9 seconds. That's the final time. And then initial time, 6 seconds. And then negative 26, this will become positive because negative times the negative, it will become positive. So 26, negative 26 meter per second plus 8 meter per second. Okay. 18. Okay. It's negative 18 meter per second. And then we will divide it by 3 seconds. That's the difference between 9 minus 6. And then you will have the answer. Hold on. Because maybe I block the answer. We have 18. 18 divided by 3. So that's 6. 6. And it should be negative. The answer should be negative 3, 6, 9, 12, 15, 86. Okay, negative 6. I'm very sorry for my handwriting. Meter per second, since it's acceleration. This is our unit. Okay, it's negative 6 meter per second squared. A mechanical object is moving west at 8, and then that's the problem. Earlier we will be showing the table. So at 6 seconds, we have 8 meter per second velocity. It's west, so it's negative. And then the target is we should provide the velocity at 9. And the acceleration earlier, we have 6, negative 6, right? Negative 6 acceleration. So we will just add negative 6 to our velocity here. So we have negative 14, negative 20, and then we have negative 26. So it's true that at 9 seconds, uh, it will generate, or it has the magnitude of velocity, which is 26 meter per second. An object accelerates from 3 meter per second to 9 meter per second in just 12 seconds early in the morning. So what is the acceleration? What is the velocity of the object at 15 seconds? So we have from 3, this will be our initial. 3 is initial, 9 is our final, and then it's in just 12 seconds. That's the time recorded. And then what's the acceleration and what is the velocity at 15 seconds? So again, if you encounter already the initial velocity and then you have the acceleration, just add the acceleration to your velocity until 15 seconds, and you will have the velocity at 15 seconds. An object accelerates from 3 meter to 9 meter per second. That's our problem earlier. These are our given variables. Initial 3, final 9 meter per second. Initial time is 0, and then final is 12. Unless in some cases the problem will really give the uh, initial time. For example, from 7 to 12 seconds. So 7 will be our initial. So in this case, the problem does not give us the value itself, but it's very understandable that the initial time is 0. And we need to find the acceleration and the velocity at 15 seconds. This will be our formula. We will substitute 9 to our final velocity minus 3, that's the initial, and then 12 minus 0. We will have 6 and 12, and this will be our acceleration, 0.5 meter per second squared. Now we have the acceleration. We will be adding this acceleration to our velocities, or yeah, velocity. And then from 3, that's our initial, right? From 3, that's our initial velocity. So you will have to, um, at 12 seconds, the, sorry, at 12 seconds, our velocity will be 9, right? 9. And then our target is at 15. So 9 plus 0.5, 9.5 plus 0.5, 10. And then at 15, the velocity is 10, zero point 0.5 meter per second. Okay. The North Star of this topic is find the find the initial velocity, get or calculate the acceleration, and then add this acceleration to your initial velocity, and then it will give you the right velocity at specific time. Just add the acceleration to your velocity. Okay. A cat immediately runs at 1.2 meter per second after escaping from a cage upon spotting a rat and changes at an unknown velocity with an acceleration of 1.4 meter per second squared at 8 seconds. With an urge of catching up the rat, let's find the unknown. We have 1.2 meter per second. That's the initial. And then 1.4 meter per second squared, obviously, that's the acceleration. And we have at 8 seconds, that's our final time. Okay. The initial time is not provided, and for sure it's going to be 0. Let's find the unknown, which is the final velocity. We do not know final velocity in this problem. We need to calculate it. So our initial time is 0, 8 is our final time. We have acceleration 1.4, and then we have 1.2 as the initial time. That's very important for us to calculate this problem. So we have the formula. Let's substitute. Let's derive since we want to find out the final velocity. So we will rearrange our formula. So we will just do the cross multiplication or cross multiplying acceleration and this change in time. And then you will have change in velocity. And then we have we have understood that there's one in there. Okay, so you can arrive this derived formula. So acceleration is equal to change in time times change in time equals to the change in velocity. So we will substitute the values. Our acceleration is 1.4. 8 is our final minus 0 initial time. We don't have the final velocity yet, minus 1.2. And then you will have 1.4 times 8, and then we will transpose later negative 1.2 to the other side of the equation to isolate final velocity variable. And then we have this answer. This is the final velocity at 8 seconds with an acceleration of 1.4 meter per second squared. The mechanical object initially moves at constant rate of negative 1.5 meter per second squared. Provide the velocity of the speed of the object at 7 seconds. We have the given, and we need to find the velocity. So we will be using the same procedure or process earlier. Let's derive, and the target is to isolate final velocity. So we will substitute the values there. 1.5, you have to substitute carefully. Okay, negative 1.5, 7 is the final time minus 0, and the initial time is 0. It does not provided in the problem. There's no specific value but 0. Okay, so this will be our final velocity. It's negative 10.5. So, in a nutshell, there are cases, maybe it will come out in your examination or in your entrance exams. If both acceleration and velocity have the same signs, it means they are speeding. It's speeding up. If If acceleration and velocity have different signs, meaning it speeds down or it's speeding down. Okay, please remember that. Same sign between acceleration and velocity, the object is s- moving fast. If ever that these two variables are having different signs, it's slowing down. Okay, I want you to try it in your notebook and yeah, try to solve it on your own to practice your skills in this concept. Okay, you can pause the video and then you can copy this problem. This one also, please pause the video and then copy the problem. All right, that's it for today. I hope you learned something and then see you again next time around. Bye for now.